Hello students, welcome to the class of teacher Meenal Pereira. In this video, we are starting with lesson number 6 of science part 1, that is refraction of light. And the points that we are going to cover in this lesson are, we will be studying about refraction of light, refractive index, we will be studying about the laws of refraction and dispersion of light. So let's begin. First, we will recall that we have already studied previously. What is meant by reflection of light? The answer is, reflection is when light bounces off an object. What are the laws of reflection? The laws of reflection are as follows. The incident ray, the reflected ray, and the normal lie in the same plane. This we have already studied in 8th standard children, that we have an incident ray, we have reflected ray, and a normal that lies in the same plane. The angle of incidence is equal to the angle of reflection. Angle of incidence, which is denoted by sign I, is equal to angle of reflection, which is denoted by sign R. And the incident ray and the reflected ray are on the opposite side of the normal. So if this is my normal, the incident ray and the reflected ray are on the opposite sides of the normal. So this we have studied about a reflection. Now let's see what is the meaning of refraction. Okay. Now we have seen that generally light travels in a straight line. And because of this, if an opaque object lies in its path, a shadow of the object is formed. Opaque means the object through which the light does not pass. We have also seen in previous classes how these shadows change due to the change in relative position of the source of light of the object. That is, in 7th standard we have studied about the shadow that is formed by point source as well as extended source. You must be remembering about umbra and penumbra, the types of shadow that are forming. But light can bend under some special circumstances as we see below. So far we were studying about bouncing of light rays. But now we will be studying about the bending of light rays. Let's see how this is happening. To understand this, we will one study experiment. Take a transparent glass and fill it with water. Dip some portion of a pencil vertically in water and observe the thickness, the portion of the pencil in water. Okay, so you can see a glass with water and a pencil is kept. Now, observe the thickness of the pencil, children. This part is, you will find that this part is less thick than this part. This part is more thicker. Now, keep the pencil inclined to water surface and observe its thickness. In both the cases, the portion of the pencil inside the water appears to be thicker. Okay, so as I told you, the portion of the pencil which is inside the water is more thicker than the portion above the water. And in the other case, the pencil appears to be broken near the surface of the water. See here you can see that as if the pencil is broken. Now, why this thing is happening? Okay, so effects are created due to change in the direction of light while coming out of the water. Okay, so now here you can see that this part of the pencil is in air. This part of the pencil is in water. Okay, so the light rays that are coming out of the water creates the effect and we feel as if this pencil is broken. But actually that is not the case. The pencil is not broken. It is just the effect. Okay, so that gives to the idea of refraction. Light changes its direction when going from one transparent medium to another transparent medium. This is called the refraction of light. Okay, so coming to the definition again, the light changes its direction. Okay, so direction of light is changes when it's going from one transparent medium to other transparent medium. Okay, so in this diagram you can see both a reflection and a refraction. This is my original ray of light. This is bouncing, that is a reflection. And here you can see that this, in this case, the second case, this ray of light is bending. It is changing in direction. This is called as a refraction. Okay, so we will be studying more details about a refraction. Now, let's study, or with the help of a small experiment, we will study how the refraction takes place. Now here we have taken a transparent medium, that is a glass slab, and we have also, or our other transparent medium is air. Now as you can see here, you can see two diagrams. First, concentrate at diagram number 1. This is my glass slab. Okay, this is incident ray. This is my normal. Now you can see that, see, the incident ray is bouncing or touching the glass slab. Okay, then it is slightly bending inside. Okay, and when it comes out again, it goes in this direction. Again, look at the path. The incident ray bouncing or coming towards the glass slab. It is slightly moving near the normal. Then it travels this way, and when it comes out of the glass slab, it is moving away from the normal. So this is my incident ray and this is my emergent ray. Okay, so here we have three things: incident ray, then the refracted ray, which is moving close to the normal, and the emergent ray that comes out of the glass slab. Okay, now concentrate at this diagram. We will study this slowly. The first refraction occurs when light rays enter the glass slab from air at N on the side PQ. So the first refraction is, this is the ray of light. This is entering from air to glass slab at N. The second refraction occurs when light rays enter air through glass at point M on side SR. Okay, so here this is the side SR, this is point M. Okay, and then the light enters the air through the glass. That means the ray of light is incident or coming from air, going inside the glass slab and coming out of the glass slab and going again in the air. For the first refraction, the angle of incidence is I. This is my I. And in the second refraction, the angle of refraction is E. See here, this is E. This is I. This is E, which is equal to I. This according to the law. On both parallel sides PQ and RS of the glass slab, the change in the direction of light ray is equal but in opposite direction. Okay, so both the parallel side, PQ is parallel to SR. We can see that the change of direction of light ray is equal. That is, I is equal to E, but it is in opposite direction. Thus, the light ray MD emerging from the glass slab is parallel to incident ray AN. Okay, so this light ray MD is parallel to incident ray MN on the side PQ of the glass slab. But the emergent ray is somewhat displaced with respect to the incident ray. Okay, so we see that the emergent ray is somewhat displaced. Now, if you look at again this diagram carefully, the blue color, that is incident ray AB. See here, when it is going in the glass slab, you can see that it has slightly moved towards the normal. Okay, so here this angle of incidence is greater than this angle of reflection, and when it comes out, the angle becomes equal. So what you have to remember is the angle of incident and the angle of emergence are equal, and there is a difference between angle of incident and angle of refraction. Okay, so this is how the light passes from one transparent medium to the next. Okay, now coming to the laws of refraction. The first law says the incident ray and the refracted ray at the point N are on the opposite side of the normal to the surface of the glass slab at point CD. Okay, so incident ray and refracted ray are on the opposite. This is my normal. They are on the opposite side of the normal, and the three, that is incident ray, the refracted ray and the normal are in the same plane. Okay, so these three are in the same plane. Then for a given pair of media, here air and glass, we have two transparent medium, air and glass. The ratio of sin I to sin R is constant. Here I is the angle of incidence and R is the angle of refraction. Okay, so now we are coming to the angle of incidence and angle of refraction. The ratio of these two angles is constant. Okay, so sin I, the ratio means division. Sin I upon sin R is a constant, and that is denoted by a letter N. N is called the refractive index of the second medium with respect to the first medium. Okay, so look at the diagram here. These two mediums are there. Okay, so N1 is the refractive index of this particular medium, N2 is the refractive index of this medium. Okay, so later we will study refractive index. Right now you keep in mind that it is a denoted, or N is denoted, or N is a symbol of refractive index. This is the second law, which is also called as Snell's law. Okay, so second law which says that the ratio is constant, it's also called Snell's law. A ray incident along the normal, that is I is equal to 0, goes forward in the same direction, that is R is equal to 0. Same thing you can see in the diagram. When the angle of incidence, that is I is equal to 0, which is shown by a dotted line, the angle of refraction is also 0. Moving further. Now we go to refractive index. In the previous one we saw what is refractive index, which is also called as index of refraction. Is a measure of bending of a ray of light when passing from one medium to another. Okay, so refraction is all about bending the light ray or changing the direction of light ray, which is denoted by a reflective or a refractive index. Okay, now the change in the direction of light ray while entering different media is different. It is related to the refractive index of the medium. The value of the refractive index is different from different media and also for light of different colors for the same medium. Now there are various transparent medium, children. We have glass, we have air, we have water, we have fog. Okay, so in all case, the value of refractive index will be different. For air, the value of refractive index for air and the value of refractive index for water is different. Not only that, but in the same medium, that is air medium, this value is different for different color. Okay, so in this diagram, you can see two medium. Okay, the one is the white one where the refractive index is N1. The second one is blue one, say water. The refractive index is N2. Okay, this is the normal. This is the angle of incidence, and you will see that the reflected or the refracted ray has bent towards the normal. The refractive index of a medium with respect to vacuum is called absolute refractive index. Okay, so with vacuum, a new concept, it is called absolute refractive index. Refractive index depends on the velocity of light in the medium. Okay, so velocity of light means the speed with which it enters the medium. So refractive index is different for different medium. With vacuum, the refractive index is called as absolute refractive index, and the refractive index depends upon the velocity of light in a particular medium. Okay, so remember a refractive index which is denoted by a letter N. Okay, and it is different for different media. Okay, let's learn little bit more about this refractive index. Okay, as we have already studied, this refractive index is denoted by symbol n and it depends upon the velocity of the light in respective medium. Now, let the velocity of light in medium 1 be v1 and in medium 2 be v2 as shown in diagram 6.3. We have two mediums here. Medium 1 is air, velocity of which is v1. Medium 2 is glass, velocity of which is v2. The refractive index of the second medium with respect to the first medium. See how I am pronouncing it. The refractive index of the second medium with respect to the first, that is 2n1, is equal to the ratio of the velocity of light in medium 1 to that in medium 2. Okay, so when I want to find the refractive index of the medium, it is a ratio. Ratio of what? Ratio of velocity of light in the two mediums. Okay, so the refractive index of second medium with respect to 1 is equal to velocity of light in medium 1, that is v1, divided by velocity of light in medium 2, that is v2. Okay, similarly, the refractive index of medium 1 with respect to medium 2. Medium 1 with respect to medium 2 is equal to v2, that is velocity of light in medium 2 divided by v1, that is velocity of light in medium 1. Okay, so see children, when I am pronouncing second with respect to first, here I am writing 2 first and then 1. And medium 1 with respect to 2, I am writing 1 first. Okay, so that you remember because that is slightly confusing. Okay, so what you say first, that number will come first. If you are telling second with respect to first, number 2 or number second will come in the front. When you will see the refractive index of medium 1 with respect to 2, 1 will come in the front. If the first medium is vacuum, then the refractive index of medium 2 is called absolute refractive index and it is written as n. Okay, so absolute refractive index of vacuum. So simply we are writing it as n because there is a formula, or as it is vacuum, it is called the absolute refractive index. Okay, so this is the formula that you are going to remember to solve the sums. Now, let's see some more phenomena based on this. Okay, now these are the three situations, okay, which are again very important for you to understand now, because based on this we will be studying certain phenomena of the nature, how the refraction takes place in different media. Okay, now here two words you can see, rare medium and denser medium. What is the meaning of rare? Rare means the particles are far away. Okay, the particles are away from each other. Like for example, that we have in cases of gas. In case of gas, the particles are away. Okay, whereas denser medium means thick, where the particles are close to each other. Okay, for example, any solid is a denser medium. Okay, so everywhere now we will be using the word rare medium and denser medium. Rare means thin medium, denser means thick medium. Okay, so now let's see how the light is traveling. First case, when a light ray passes from a rare medium to denser medium, it bends towards the normal. This is a rare medium, this is a denser medium. So suppose the light ray is coming from air to glass slab, it is bending towards the normal. That means it is coming close to the normal. Okay, now second case. When a light ray passes from a denser medium to a rare medium, it bends away from the normal. Now, this is a glass slab, this is air. So now the light ray is coming out from the glass slab and going to air. That is from denser, when it is going to rare, it bends away from the normal. As you can see that this is my normal and the blue color ray or the refracted ray or emergent ray is moving away from the normal. Okay, and when a light ray is incident normally, that is at the boundary between the two media, it does not change its direction and hence does not get refracted. Okay, now see here. This is a rare medium, this is a denser medium. It's incident normally at 90 degrees or at 0. Okay, so at this C, we can say that there is no refraction as such, but it passes straight. So it is coming from here, it is going into this denser media and will move out. Okay, so there is no refraction as such when the incident ray is normal to the boundary between the media. Okay, so I hope all this phenomenon are clear to you. So in this video, we studied about the difference between reflection and refraction. Reflection is bouncing, refraction is bending. Please remember these two words properly, bouncing and bending. Okay, then we studied about the laws of refraction. We also studied what is called as refractive index, that is the extent to which the light ray or the light ray bends in a refractive medium. Okay, then we also studied the formula by which we can calculate the refractive index, and we studied about the refraction of light in different media. Okay, so I hope this is clear to everyone. Important lesson. Please read. Thank you very much. Take care.